Now here's another one that has a slight problem.
I can't take this!
Oh, just hear me out. It's not as bad as you think. Y prime equals the square root of y squared minus 9. Initial condition 5, 3. That is, y of 5 is 3. In other words, when x is 5, y is 3. I don't know if you see the problem. Y equals 3 is on the border of a legitimate region, but it's not in the interior. So since it's not in the interior, our initial condition is on the border, hence not in the interior, so therefore we cannot say that we'll be able to find a unique solution for that. I won't talk about how to solve it. Right now I can't even see how to solve it, but if we did try to solve it, our IC being on the border instead of in the interior would not guarantee us a unique solution.
I know!
Well, I'm glad you know. So let's look at one more here. Solving a differential equation by the method of substitution. Okay, how interesting that might be. Y prime equals x over y. We rewrite it as dy dx equals x over y, and actually then we can separate using algebra into y dy equals x dx. Now, that's not the method of substitution, that's the method of separation. Of variables, which is actually a future lesson. But we can now separate the two sides. This side only has y, this side only has x, and integrate this side. Integrating y, we get y squared over 2. Integrating x, we get x squared over 2, so we got y squared over 2 equals x squared over 2 plus c. Well, it wouldn't take much for you to realize that we could multiply both sides of this by 2 and get rid of the fraction. Then we'd have a 2 times c here, but it's still arbitrary, so we'll just call it c. If you want, make it c prime, but it's some arbitrary constant. So y squared minus x squared, subtracting this on both sides, equals a constant. And an explicit solution would be y equals, actually two explicit solutions, y equals plus or minus square root of x squared plus c. We can see some of the solutions as the family of hyperbola here, because I drew them. And so I can give you different values of c. Here's another one, see? Here's another one. And you can probably see this changing. And maybe I'll put in a positive value here too. So there, see how that one changed? And here I'll put in a different value of x. Or sorry, different values for c. So these are actually two explicit solutions for this equation, but both of them together make up the graph that is the equation of this solution of this equation. Okay, I hope that makes a little bit of sense.
Okay.
Good.